In this video, we're going to talk about limiting reagents. So what have we learned so far? We have learned how to solve stoichiometry questions with one reagent being in excess and the other reagent value given to you. So when constructing the BCA table, what we could do here is we can ignore the excess reagent to save time. For example, since the question here says water is in excess, and I know the amount of sodium oxide, the other reagent, which is 120 grams, I can just ignore water and solve for the amount of sodium hydroxide produced from sodium oxide. But what if the questions give you values for both reagents? Well, now you cannot ignore water because values are given for both reagents. Now, this is a classic limiting reagent question in stoichiometry. So how do I know when I'm dealing with limiting reagent questions? Well, usually the signal is when you're given values for more than one reagent, this is how you know you are dealing with a limiting reagent question. So how do you do these kind of questions right here? So let's start with something easy first. So recall that chemical equations are nothing but recipes. So I have this chemical equation / recipe here. 2 bread plus 1 cheese will give me 1 cheese sandwich. Now, what if there's a question right here? You have 4 bread, 4 cheese. How many sandwiches can you make? Again, this is a limiting reagent question because you are given both the amount, actual value for both of the reagents. So how can I quickly solve for this? Well, what we can do here is we can ask this key question. Don't forget this question. How many times can I repeat the recipe given each ingredient? So here's what I can do. What I'm doing here is that I'm going to temporarily ignore cheese. I'm going to cross it out. And I'm going to ask myself, with 4 bread given to me, how many times can I repeat the recipe? Given that each recipe, so each time I repeat my recipe, I need 2 bread. Well, it will be 2 times because if I'm provided with 4 bread, each recipe calls for 2 bread. It will be 4 divided by 2, and I can repeat the recipe twice. So now I'm going to ignore the bread, and I'm going to try to determine how many how many recipe I can repeat given 4 slices of cheese. So I'll give you some time to figure this out. Pause this video and come back. Yes, it will be 4 times because each time you repeat the recipe, you need to use 1 cheese. Now you have 4 cheese, so you can repeat the recipe 4 times. 4 divided by 1, 4 times. So since I can only repeat the recipe 2 times with bread therefore is the limiting reagent. And the cheese will be the excess reagent. So let's take a look at a few practice here to solidify our understanding. So what you're seeing right here is a simplified chemical reaction or chemical equation. Again, that's just a recipe. Moving forward, I'm going to refer to as recipe. Now, the ICE that you see here is the same as BCA. It's just that in Chemistry 12, you will not be using BCA, you will be using ICE, but they're the same thing essentially. So again, I'm going to ask myself this question. First of all, I know this is a limiting reagent question since both of the reagents have a value given to me. So I'm going to ask, how many times can I repeat the recipe given each reagent? So for A, it will be 8 times because 1 A is needed per recipe. So 8 divided by 1 will be 8 times. Now, how about B? Well, it'll be 3 times because 2B is needed per recipe. So if I'm given 6B, 6 divided by 2, it will be 3 times. So 2B in this case will, B in this case will be my limiting reagent. A will be the access reagent. So we're gonna do 3 more practice. Feel free to pause every time before you hear the answer. So here's the question. 3A plus 4B, that will give you 4C and 3D. And you're given 9A as well as 14B. So again, limiting reagent question, ask yourself this question. How many times can I repeat the recipe given each reagent? Again, cover the B and figure out how many times you can repeat the recipe given 9A. So A will be 3 times because 3A is needed per recipe, right? So 9 is given to you. 3A is needed per recipe, 9 divided by 3 times. And now let's determine how many times we can repeat the recipe looking at B. Again, I'm going to cover the A. I'm going to ignore A for now. So good, it will be 3.5 times because 4B is needed per recipe. So I have 14B given to me, but each recipe needs 4B. So 14 divided by 4, 3.5. So which one is going to be your limiting reagent? Yes, it's going to be A because 3 is less than 3.5 times. So with that being said, A is the limiting reagent. Hopefully you're following along here. Let's go to the next question. So 3A combined with 2B, that should give you 5C and 4D, and you're given 10A as well as 8B. The question is now, how many times, again, can you repeat the recipe given each reagent? Again, limiting reagent question here. So for A will be 3.33 times because you're given 10A, and 3A is needed per recipe. So 10 divided by 3, 3.33 times can be repeated if I have 10A. Now, if I have 8B, then I can repeat the recipe 4 times because 2B is needed per recipe. So now, which one is my limiting reagent? Well, it's going to be A because 3.33 is less than 4. All right, last question here. So with 3A plus 5B, that will give you 5C and 4D. So my reagent amount for A is A, for B is 16. So again, limiting reagent question, how many times can I repeat the recipe given each reagent? So for A, it's going to be 2.67 times because 3A is needed per recipe. So I have 8 and 3 is needed per recipe. So 8 divided by 3, that will be 2.67 times. Now how about B? Well, given 16B and in each recipe I need 5B, so I can repeat the experiment 3.2 times or the recipe 3.2 times. So which one is your limiting reagent? It's going to be A because 2.67 is less than 3.2 times. So as you can see here, right now we have successfully determined which one is limiting and which one is access reagent. But one thing we need to figure out is filling out the BCA table or the ICE table. So first of all, again, this is the first question. We already looked at that. We already determined B to be limiting reagent, so that's why I'm circling it to remind myself this is my limiting reagent. So I'm going to fill out the ICE table with the limiting reagent first. So for the limiting reagent first, I have 6B. Limiting reagent means I'm going to have to use up every B, every single B in the reaction. And with that being said, at the end of the reaction, I should have none left. And now how much A would I be consuming? And since A is the access reagent, what is the leftover? So to determine how much is being consumed, the change column, we need to use the limiting reagent. So I'm given 6B, and given the mole ratio between A and B is 1 to 2, I know that 3A will be consumed in the reaction. Now, what will be the E column, the after the reaction? How much leftover would I have for A? Well, it'll be A plus -3 or 8 minus 3. That will give me 5. So how about C and D? How much C and D will I be able to make? Well, again, you have to go back to your limiting reagent to help you figure out this question. The amount of product produced as well as the amount of excess reagent consumed is always determined by the limiting reagent, the amount of limiting reagent. So this is exactly what I'm going to do here. I started with 6B. Given the mole ratio between C and B is 1 to 2, that will give me 3C. Now, how about the E column, the after the reaction? How much do I actually have? Well, I had none to begin with, and now I made 3C, then I should have 3C left. 3C made. My bad, 3C made. Now, how about D? Again, I have 6B. The mole ratio between D and B is 2 to 2, so that means 6D will be made. So at the end of the reaction, I should have 0 plus 6D left. Let's take a look at the next example here. So again, we have already looked at this question previously. So we already determined A to be the limiting reagent. So therefore, I'm circling it in red. So I'm going to fill out that part first. Okay, so again, I'm going to consume every single A. So that's why I'm doing -8 here, -8 here. Again, limiting reagent, I should have nothing left, no A left at the end of the reaction. How about B? Again, to determine how much B is being consumed or was consumed in the reaction, I need to go to the limiting reagents. So I will have -8A, negative being I'm consuming because B is a reagent, and I'm going to multiply by 5, the mole ratio between B and A, so 5B over 3A, and that will give me 13.3B being consumed. So that's actually -13.3. I forgot that negative there. So if you add the I column and the C column together, or the B and C column together, and that will give you 2.67. So the before and change column. So 2.67B will be the leftover amount. Now how about C and D? How much C can I make? Again, the amount of product produced is also determined by the limiting reagent, the amount of limiting reagent. So 8A multiplied by the mole ratio between C and A, that will give me 13.3. The 5C over 3A, again, I get it from my recipe, my balanced chemical equation. Now, please note it's going to be a positive 8A here because I am producing, I'm making stuff. So it's not negative here. I'm not consuming. So if I add 0 to 13.3, that will give me 13.3C. Now go to the D. How much D can I make? Again, 8A multiplied by the mole ratio between D and A, so that's 4D over 3A. That will give you 10.7 D. To begin with, I have no D to begin with, so 0 plus 10.7, that should give me 10.7 D. So hopefully, at the end of this video, that's it for today's video. Hopefully you've gotten a basic understanding of limiting reagent. Now in the next video, we're going to touch on some actual chemical equation question, some actual limiting reagent question that you will see on your practice worksheet as well as your test, as well as quizzes. Now, what I would like you to do right now is if you go to Teams, go to our class notebook, there should be a worksheet on the ICE table, just like this. or again, ICE table is the same as BCA table, and I would like you to do some practice first before you move on to the next video. So I will see you in the next video. If you like this video, please give it a thumbs up. Thank you.